Today's lecture, we are going to discuss about the texture of sedimentary rocks. Texture means what? If you remember the previous lectures, texture of any rock, which means it is the grain to grain relationship of minerals in a rock. So when you're talking about a sedimentary rock, these minerals means what? The minerals are actually the grains or the sediments which are deriving from the pre-existing rocks. So one mineral, one grain of a sedimentary rock can be a one mineral, or it can be a small fragment of a rock even. Okay, so that are the possibilities. So when we here in the sedimentary rocks, when we talk about the texture, we are talking about the different parameters of these independent grains. That may be even a single mineral, or that may be a small fraction of a rock or a small portion of a rock. So this texture of a sedimentary rocks we study basically on 5 different parameters. First one, it is the origin of the grain. Origin of the grain means that how, from where these grains are originating, what is the process of formation of this sediment what we are talking about. Second is the size of the grain, that whether the grain is of a small size of clay and silt, or it may be a boulder and cobble. And the third one, it is the shape of the grain, that what is, whether it is a square shape, circular, triangular. We'll see in detail what exactly it is, but it is what we are going to study about the shape of the grain. Then we discussed about the packing, that how these sediments are packed. And then we discuss about the fabric. So fabric means how these sediments are arranged within a sedimentary rock. So these are the main 5 parameters by which we are going to study the texture of a sedimentary rock. Okay, so we'll discuss it one by one. What are those? Origin of grain, size of grain, shape of grain, packing, and fabric. Okay, so we'll discuss it one by one. The first one, it is the origin of the grain. So you all know right now by the time that we discussed basically 2 processes of origin of a sediment. They are either a clastic sediments or by a non-clastic sediments. So clastic sediments are originating by in different environments or different processes, by the water, by wind, or by glacier, or by landslide. All different varieties of processes which effectively break the pre-existing rocks and generating a single grain. We call it as a clastic sedimentary rocks. That is the texture of a sedimentary rock based on its origin. Then non-clastic sedimentary rock, one example is a stalagmite or stalactite, which are produced by the process of chemical action. Okay, so these are the 2 basic categories of textures what we can see in a rock. So when I get a sedimentary rock, I first identify whether it is a clastic type of texture or a non-clastic type of texture. Clastic textures means these are derived mechanically, eroded, deposited, then lithified. Lithification is the process we studied in the last lecture. So that kind of rock, we call it as a clastic type of sedimentary rocks. And if it is not clastic, and if it is formed by either by mechanical process or a chemical process, we call it as a non-clastic sedimentary rocks. Second one, it is the size of the grain. So when you talk about the size of the grain means the size of the sediment, which can be of a small size to a large size, like a clay size to a boulder or a gravel size particles. So those are all possibilities. So by meaning the size of the grains, what we are in this sedimentary structure, in sedimentary rock characterization, the grains, the longest axis through which it passes, so that diameter we are taking as the size of the grain. So in an ideal condition, when you get a grain, so it should have a longer axis and a shorter axis and an intermediate axis. But if you see in nature, that is not a very true sense. We may not get that kind of proper shapes. Okay, we will get different varieties of number of different shapes available for a grain. So sometimes it may be large in one direction, and there is all other directions are same. Sometimes it may be not exactly as spherical or rounded in shape. So in that kind of situations, what we go for to represent the size of the grain is what we call it as a calculated diameter. Okay, so if you get a perfect spherical grains, it is easy for us to measure the longest diameter and mention that it is the diameter of that. But in some cases, we calculate it. What we calculate? We calculate the volume of this particular grain. How we can calculate the volume of this particular grain? We can use number of 3D measurements we can do. The best way is to put take the grain and put it in the water and see that how much volume of water it replaces. And if you know the volume of water it replaces, then we can calculate the radius and then the diameter of that particular grain. Because volume of a material, it is given by the equation that is 4 by 3 pi r cube, where only unknown parameter is the radius. So now if you know the volume of this grain, then by substituting the values of 4, 3 and pi, the pi value, we will get the r value of that particular sediment. Okay, so that process we call it as a calculated diameter. Correct. So this process will give you this, and if you are doing this exercise in the laboratory, you will study it in the geotechnical one in the upcoming semesters. So we'll be characterizing the sediments by doing a sieve method. Sieve method is that we take different sieves of having different size of openings and we put the grain into that the largest sieve. Then it will pass through different sieves which actually will have the reduced size of openings, and when you sieve that in a sequence, we'll get gradations, the coarser sediments on the topmost sieve, then the finer sediment, then the next sediment, so that way we can find out the size of the grain. So there also we assume that the sediments are passing through a particular size, so that means that diameter we are taking as the diameter of that particular grain. Okay, so based on that characteristics, we classify the things into different categories. So, okay, first one, it is a coarse grain. When you're talking about the coarse grain, we are talking about the diameter of that grain. If it is more than 254 millimeter, then we call it as a boulder size sediment. And if it is 64 to 254 millimeter, we call it as a cobble size. And pebbles will have a diameter of 2 to 64 millimeter. And the medium grains, we call these are the sand. This term may be very common, very well aware of you people or of you, because this is the material what we use in the industry where the cement is mixed with the finer aggregates or the sand or the reti, what we call, that is the name sand is given to this particular size, and the size is 2 millimeter to 0.0625 millimeter, that is 1 divided by 16. So we call it as a 2 millimeter to 1 by 16th of a millimeter is what we call it as the size of a sand grain. So whatever the sediments which are of that particular diameter size, we call it as a sand grain, and below that it is less than 0.0625 millimeter to 0.0039 millimeter, or 1 by 16 to 1 by 256 of a millimeter size, we call it as a silt, and less than that, that is 33 microns, is called a, or 0.0039 millimeter, or 1 by 256 of millimeter size. If the diameter is less than that, we call it as a clay. Okay, so this is what the different type of size fractions we have available. And if you see a detail, characteristics of this size fractions, here in the first place you will see the diameters in millimeter, starting from 256, then it comes down to around 0.0039 millimeter, and the second is a typical is a different scale instead of millimeter, because when you see it in the millimeter, there are so many fractional values here, so it is actually difficult in the computation purposes. So there is another scale which is representing the size of the grains, that we call it as a phi scale. Phi scale is nothing but it is the negative logarithm of this millimeter value by a base 2. Okay, so if you take the negative logarithm of 266 minus log 256 by a base 2, we will get the value minus 8. So by this we are able to understand, okay, the minus 8 phi scale represents a size of 256 millimeter, whereas plus 8 represents a 1 by 256. Okay, so that is why if you see here there are so many fractions. All these fractions what are written here, 1 by 16, that all can be written into the power of 2. Okay, so we can write it in the power of 2. That is why all these different fractions are having the 1 by 16, 1 by 256 and all like that. Okay, so this is the scale here, the same summarized scale what we can see here: boulders, cobbles, pebbles and granules, and sand also we can to divide into different fractions. So 2 millimeter to 1 by 16th of a millimeter is the sand. Here also then will be fine, medium, coarse, very coarse. And then silt also will have different characteristics. Then clay also will have different very fine silt and clay sediments. So based on this particular size, what we get is the type of rocks. If you have a rock which is made up of gravel size particles, we call it as a conglomerate rock or a breccia. If you remember, yesterday we discussed the same terminologies. The rocks of sedimentary origin which are made up of gravel size particles, we call it as a conglomerate. And if it is made up of a sand size particles, so all the rocks which are made up of sand, when I say all the rocks which are made up of sand, which indicates the rocks which are made up of grains which are of a size 2 millimeter to 1 by millimeter size of grain, so that we call it as a sandstone. And if it is of siltstone and shale or claystone, which are made up of silt size or clay size particles. Okay, so this is the classification of or the study of size of a grain. So we discussed about the origin of a grain, then we discussed about the size of the grain. Now the next texture is based on the shape of the grain. So if you see it in the slide, you can see that the first image, this image and this image is having something different. What is it different? The sphericity is different. What is that sphericity means? Sphericity means is the extent at which the particles, the things which is different here, it is the roundness. Okay, roundness is the factor which indicates that how similar a particular grain to the sphere. Okay, again making confusing, let me make it clear. So the roundness of a grain which indicates that is the sharpness of edges and corners. Okay, so sharpness of edges and corners, if you take here, there are here in the first image we'll find a number of sharp edges and corners, whereas in this grain, if you see, the surfaces are very smooth. Why is it so? Because this grain, which has gone through a number of erosion depositional processes and finally which converted to a shape or the edges and corners which are very well rounded. Okay, so here in the first image we'll get an angular shape, angular sediment, whereas in the last we'll get a rounded shape. Whereas the second thing, if you see here, how nearer to a sphere how nearer the sediment to a sphere is called the sphericity of that grain. Okay, so that defines that extent at which the particle approach to a sphere. So how closer that it is to a sphere shape. So here in this case, all the things are of low sphericity, but all these things are of high sphericity. Okay, all these things are of high in sphericity, but what varies here, it is the roundness is varying. Okay, so in this case, the rocks are made up of high sphericity and angular fragments. Here in this case, the rock is made up of high sphericity and angular fragments, whereas here it is low sphericity and angular rounded fragments. Okay, so that is about the shape of the grains. Now the next parameter is how these grains are arranged. So the arrangement of these grains in the rock. So here in this case, if you see, these all grains are arranged quite parallel to the direction of current. Current means the direction of flow of the material which is transporting this material, these sediments. All these are well oriented. Whereas in this case, you see that these are all randomly oriented. The long axis of these grains are not properly oriented. So this actually indicates the fabric of the rock. Then the next one, it is the packing. Packing, there are two basic type of packing. This is called a hexagonal packing. So in between two grains, so one grain which occupy the area between two grains, where in this case the grains are 1 hour above. So this we call it as a cubic packing, and this we call it as a hexagonal packing. Okay, so these all parameters together actually is an indication of the formation of these sedimentary rocks. So when I say that, I'll show you a video at the end, so that will make you clear that how these things have been interpreted. Okay, so let me finish this and we will just see that video. So packing is that. Then another parameter, it is the sorting. Sorting, you know that, let us sort it out. Means let us make the things which are of same size together. We call it as a well sorted sediments. And the sediments which are all having varying sizes or shapes or parameters together, we call it as a unsorted sediments. Now I'll ask a small question here. If you remember yesterday when we were talking about the environment of deposition, one deposit is formed on a glacial environment and another deposit formed on a wind or aeolian environment. Which will have which sediment or which rocks you expect to be a well sorted in nature, this aeolian environment or a glacial environment? So if you talk in terms of the sorting, so the glacial environment, the sediments are going to be mostly unsorted because the glacial is not having any kind of selection during the picking of the sediments. It picks everything which comes under the glacial or the ice. Whereas in the case of aeolian, we are going to get more systematically arranged, well sorted sediments, because wind is having a property that will only pick a particular range of sediment and it only deposits uniformly that particular kind of sediment. So the wind deposits are mostly going to be well sorted in nature. So when you get a rock type on the surface, and if you see that rock type and the rock type is all having same size of sediment, then it is an indication of the weathering conditions which were perceived on that particular area. Why I'm saying this, because an area which we see today is having a very good rain and very good climatic condition might be a arid wind-blown region in the past, because the climate of our surface varies time to time. Our surface has seen different number of varieties of climatic sequences in the geological history. So a dune or an area what we see today, or a wind-blown area or a desert area what we see today, or that may convert to another green area in the futures. In the future means in thousands or millions of years later. Or the area what we are seeing today as a green forested land might be a arid desert in the geological past. That means in millions of years before. So that kind of climatic changes are there, because when we study the area location for any civil engineering construction activity, so we are going to do the construction on a rock or a soil which is deposited in the past. So the soil what we are using for the construction is the characteristics of that soil or a rock depends on that in what environment that sediments have been deposited, and that understanding will help a civil engineer always to take a correct decision, because in different environments, different phases, the lateral extension, vertical extension, all these things vary. Okay, for example, if you are talking about a wind-blown deposit, wind-blown deposits will have a uniform nature in a large aerial distance, because wind is having a characteristics when it affect the region, it affects a larger region. But if you're talking about a glacier region, the glacier deposits may not extend very large region, and when you move one place to another place, the characteristics vary, the characteristics of the sediment vary. So that kind of the facies identification, in what kind of environment these rocks have been formed. So that identification and understanding will help the civil engineer to take a proper decision on the subsurface or the foundation characteristics or the material characteristics materials what you are going to use for the construction. So these all parameters together is actually going to help us finding out the correct environment of deposition and the characteristics or the strength point of view of the sediments. So these are the basic parameters by which we are going to discuss. So packing and the fabric we have discussed, the sorting, packing we discussed, shape of grain we have discussed, size of grain we have discussed, origin of grain we have discussed.